For any exam-related queries, call us at +1 678 648 4277. You can mail us at info@livexamhelper.com or reach us at https://www.livexamhelper.com. Problem 1 Prob 2.16.5 A planar region, shown in Table 2.16.1, is filled by an inhomogeneous dielectric, with a permittivity that depends on X. The free charge density is 0. Show that the potential distribution is where B. Show that the transfer relations are livexamhelper.com. Problem 2. Prob 4.3.3 The moving member of an EQS device takes the form of a sheet, supporting the surface charge of and moving in the z direction, as shown in Fig. P 4.3.3 Electrodes on the adjacent walls constrain the potentials there. Courtesy of MIT Press. Used with permission. Problem 4.3.3 in Melcher, James R. Continuum Electro Mechanics. Cambridge, Massachusetts, MIT Press, 1981, p. 4.57. ISBN 9780262131650. Problem 3. A general right-handed orthogonal curvilinear coordinate system is described by variables u, v, w, where livexamhelper.com. Since the incremental coordinate quantities do, dv, and dul do not necessarily have units of length, the differential length elements must be multiplied by coefficients that generally are a function of u, v, and w. A. What are the h coefficients for the Cartesian, cylindrical, and spherical coordinate systems? livexamhelper.com. B. What is the gradient of any function f, u, v, w? C. What is the area of each surface and the volume of a differential size volume element in the u, v, w space? D. What are the curl and divergence of the vector? E. What is the scalar Laplacian, f? Check your results of B, E for the three basic coordinate systems. 1. Differential operators in cylindrical and spherical coordinates if r, phi, and z are circular cylindrical coordinates and are unit vectors in the directions of increasing values of the corresponding coordinates. livexamhelper.com. If r, theta, and phi are spherical coordinates and the directions of increasing values of the corresponding coordinates are unit vectors in if r, theta, and phi are spherical coordinates, the directions of increasing values of the corresponding coordinates are unit vectors in livexamhelper.com. 2. Solutions of Laplace's equations. A. Rectangular coordinates, 2 dimensions, independent of z. B. Cylindrical coordinates, 2 dimensions, independent of z. C. Spherical coordinates, 2 dimensions, independent of phi. livexamhelper.com. Problem 1 Prob 2.16.5 Gauss law and E equals requires that if there is no free charge for the given exponential dependence of the permittivity, the x dependence of the coefficients in this expression factors out and it again reduces to a constant coefficient expression in terms of the complex amplitude forms from Table 2.16.1. EQ 2 requires that thus, solutions have the form exp, px, where p equals livexamhelper.com. The linear combination of these that satisfies the conditions that on the upper and lower surfaces respectively is as given in the problem. The displacement vector is then evaluated as evaluation of this expression at the respective surfaces then gives the transfer relations summarized in the problem. Problem 2. Prob 4.3.3. livexamhelper.com. Figure 1. force per unit area on middle charged surface C/D, is found using the Maxwell stress tensor, imaged by MIT OpenCourseWare. With positions as designated in the sketch, the total force per unit area is with the understanding that the surface charge on the sheet is a given quantity, boundary conditions reflecting the continuity of tangential electric field at the three surfaces, and that Gauss law be satisfied through the sheet. Our bulk relations are given by Table 2.16.1. In the upper region and in the lower. LiveExamHelper.com. In view of EQ6, EQ5 becomes. So what is now required is the amplitude the surface charge, given by EQ6, as the difference follows in terms of the potentials from taking the difference of x. 7, second row, and 8, first row. The resulting expression is solved for. Substituted into EQ9, where the self-terms in are imaginary and can therefore be dropped, the force is expressed in terms of the given excitations. B. Translation of the given excitations into complex amplitudes gives. Thus, with the even excitation, we're LiveExamHelper.com. And with the odd excitation, FZZ equals 0. C. This is a specific case from part B, with omega equals 0 and delta equals lambda/4. Thus, the sign is consistent with the sketch of charge distribution on the sheet and electric field due to the potentials on the walls sketched. Figure 2, potentials equals minus V0 cos kz shown with surface charge sigma F equals sigma 0 sin kz, imaged by MIT OpenCourseWare. LiveExamHelper.com. Problem 3a. Cartesian cylindrical spherical hx equals 1 hour equals 1 hour equals 1 high equals 1 h phi equals r h theta equals r hertz equals 1 hertz equals 1 h phi equals r sin theta. B. C. LiveExamHelper.com. D. Divergence. Figure 3, contour for determining, imaged by MIT OpenCourseWare. LiveExamHelper.com. Curl. Similarly. LiveExamHelper.com.